Hello everyone, my group is Estefania Salinas, Isabela Seguro, Jose Vélez, and I, Leandro Barón, are going to talk to you about formulation and project management of the clinker grinding and transportation process. Okay, project history. It is necessary to grind clinker from mesh A to mesh 800, and this in its transportation since 120 meters horizontally and 10 meters vertically to its storage with a mass flow of the 380 meters per hour. Okay, and clinker manufacturing process. Here in clinker manufacturing process, first preparation of raw materials, limestone, iron ore, clay, sand, and plaster. Second, grinding of raw material to obtain raw clinker, and then calcination of the raw clinker in a furnace to obtain clinker. Then clinker cooling after clinker grinding, clinker transport to, and finally clinker storage.
The grinding is the last step of the fragmentation process for the particle size reduction. It must be adjusted to the conditions of the problem. For this process, it must be capable of treating 380 tons per hour and be able to work with an entrance of a mesh 8 size and have to give an exit of an 800 mesh. There are There are several types of mills. One of them is the ball mill. It is used for the treatment of minerals and the manufacture of cement. The production of clinker is one of a typical example of these mills. The grinding elements are steel balls. Sometimes they are of different sizes. They apply impact and attrition forces. And the disc mill is used in also many fields, such as mineral treatment, ceramics, and food. The grinding element are steel discs, and they apply shear forces. There are a couple of differences between those two types of mills, the ball mill and the disc mill. The ball mill is designed to grind hard and semi-hard materials with a feed size of 30 millimeters and an output size of 10 micrometers. And the disc mill could grind any kind of material, could be hard, semi-hard, and brittle, and the feed size could be around 20 millimeters, and the output size would be around 20 micrometers. For this process, the disc mill option will be discarded due to the final particle diameter, which is not the one required for this process because it is around 20 micrometers and not around 15 micrometers, which is mesh 800, which could be achieved with a mill ball. So the option for this process would be the mill ball. We have two options of ball mills. The first one is the ISO 9001 ball mill, and the other one is the FTM ball mill. They have three similarities and one difference. The required power of the mixture of clinker would require 5428.6 kilowatts, and the power delivered by both mills would be also the same, and it would be around 4,500 kilowatts. And the monthly operational cost will also be the same, which is 393,893,787.4 Colombian pesos. And the only difference would be on the equipment cost, which for the first one, the ISO 9001 would be 3 million, oh, I'm sorry, 316 million and 720,000 Colombian pesos. And for the other one, the FTM ball mill, would be 185 million Colombian pesos.
Previously, we discussed the means of transportation for our specific project issue. That's why the pneumatic conveyor would travel horizontally and vertically, adding up to 130 meters, and the conveyor belt would travel approximately 120 meters with a 4.7-degree tilt. The pneumatic conveyor meets the criterion. It can take products through long distance, horizontally and vertically. It is specific to the particle size that needs to be transported and has a low energy consumption. The conveyor belt also meets the criterion, since it can take products through long distance, horizontally or tilted, with a variable particle size and has a low energy consumption. To make a comparison, the pneumatic conveyor is simple to design and install, uses low speed to prevent system wear, which reduces the maintenance cost, and the system is close to the environment, which is very important since the clinker is hygroscopic. The conveyor belt has a simple design, produces minimal wear of the transported material, has an easy maintenance, and can be designed to be a covered system. One of its disadvantages is that the product can be exposed to the air moisture and can cause pollution by dispersibility. We are keeping both options, since later on the project the actual costs of the overall system will be discussed, including the shipping of the material, installing, maintenance, and operation. And that will help to decide which technology is best to use. For the pneumatic system, 6 CG80 air blowers are needed to transport this 380 tons per hour of clinker. The power required per blower is 26.25 kilowatts. The cost of that equipment is 1,900,000 Colombian pesos. The whole pneumatic system, including the 6 air blowers and the plumbing, cost 13,300,000 Colombian pesos, and the monthly operational cost for the system is 11,450,000 Colombian pesos. The XKJ conveyor belt costs up to 97,300,000 Colombian pesos, delivering a power of 7.5 kilowatts and having a monthly operational costs of 550,000 Colombian pesos.
Some analysis of the mill. The machines are used correctly and well located, and each one correctly fulfills its function. Wages is carried out to control the quality of the raw materials. Humidity control of the percentage of impurities. Weaknesses, lack of the marketing area and often serial control. When the machine doesn't have it 13.5% of waste opportunity strategies aligned with complementary products. Due to that, quality of raw material, the mill audit operation every month of the year. Thus, there is not in the sector before the mill machine deliver machine efficiency to after a good service. The climate effective storage of raw material, and if the case arise, it also influence of the obtain of raw materials. Strange, easy flow control, weaknesses require speed control, opportunities, easy to manufacture according to need, travel, operates horizontal pace on the floor.